Okay, so now we're going to start looking at some applications of the derivative. First applications are really just the calculus applications, and then we'll get to some more general applications later. So the first thing is looking at maxima and minima. So looking for a maximum or a minimum or more than one if there are. Okay, so here let's take a look graphically first. So take a look at this graph. So my question is, are there any maxima or minima? In other words, is there a maximum of the function and or a minimum of the function? Well, yeah, definitely. It looks like this point up here is the highest point for the entire function. All right, so I think I would call that a maximum. Okay, so I'm going to call it a maximum, but I'm going to leave a little space above it. All right, so that's a maximum for the function. Now, is there a minimum of the function? Well, it doesn't look like there's any lowest value because we have the function going to negative infinity on both ends there. So there's no lowest value. All right, so there's no overall minimum. Now, interestingly enough, we have these other 2 points here that aren't absolute maxima, but they seem to be something of interest, and that's the point here and the point here. All right, so what do we make of these? Well, they are a maximum and a minimum for everything that's nearby. So we want to give them a name. So that's why we're going to distinguish between things that are overall the maximum and things that are just nearby the maximum. So going back to the top one, I'm going to call this one an absolute maximum because it's the maximum of the entire function. All right. So this other one, I'm actually going to call a relative maximum. Okay. And then similarly, I'm going to call this point a relative minimum. And so we see that we have a couple of relative points here, a relative max and a relative min. We do not have any absolute minimum because there's no overall minimum. Now, yes, it is true that the absolute maximum is also a relative maximum because what we're talking about with these relative max and mins is it the highest or lowest point for some interval around it? And certainly that one is. So that's what, looking forward, we're going to have to distinguish between absolute and relative. And we're actually going to have some alternate terms from that for those global for absolute and local for relative. All right, so let's look at a definition of what we're talking about. First, let's look about these absolute or global extreme. So let F be defined on a set containing C. F of C is the absolute global minimum of F on D if F of C is less than or equal to F of X for all X in D. Well, that makes sense. So this value, F of C, is the lowest overall on set D if it's always less than or equal to any other value in that set. Okay. On the flip side, F of C is the absolute or global maximum of F on D if F of C is always bigger than or equal to any F of X for all X in D. Okay, so that's just a way of formally saying what we were describing on the graph. Okay, so let's see a very important thing that we can, statement that we can make here is the extreme value theorem. And it states that if f is continuous on a closed interval, then f has both an absolute minimum and an absolute maximum on the interval. Okay, so obviously two big requirements. The function has to be continuous and it has to be closed on the closed interval for us to make this guarantee. So the meaning is that if we have f continuous on closed interval, then we can guarantee an absolute max and an absolute min. Okay, so we can make that guarantee. Obviously, let's take a look and see what we would mean here if we had a graph that let's say is, let's take a closed interval here like this. Okay, and obviously it's continuous on this closed interval, and indeed, yes, we do get an absolute maximum and we get an absolute minimum. Now, if we had something that wasn't continuous, so let's say we had something like this. Well, in this case, we certainly we do still get an absolute minimum, but we don't have any absolute max. And the reason is the point up top here can't be an absolute max because it's open. So there's all these potential maxima leading up to it, but we never reach any absolute maximum. Now, this is not a violation of the theorem that we said. This was not continuous, so we didn't have that guarantee, and therefore we didn't get it. We didn't get the result. Now, it could have been not continuous and we might still have gotten the result. So again, it's about the guarantee, whether we can guarantee we'll have an absolute max or absolute min.